Welcome viewers, in this video we will see the octal to hexadecimal, octal number system to hexadecimal number system. Subscribe this channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. So we will go to the topic octal to hexadecimal. This is coming under grouping techniques. Grouping technique means octal means the binary number should be grouped into 3 digits. Hexadecimal means then the binary number should be grouped into 4 digits, so that it is coming under grouping technique. And also it can be converted into 2 stages. The given octal number should converted into binary first, then binary is converted into hexadecimal. There are 2 stages. Direct conversion is not there. We need have only the indirect conversion, that is from octal to binary, binary to hexadecimal. First we will go octal to binary. How will we convert this octal to binary? This octal number given is 32. Write 3 separately, 2 separately. Convert 3 into binary, 2 into binary and write it in 3 digits. That's why I already told. So grouping technique means octal means 3 digits, right? The given octal number is 32. It is written separately. 3 written separately, 2 written separately. 3 should be converted into binary and written in 3 digits. 2 should be converted into binary and written in 3 digits. First we will take 3, right? 3 is there. While converting binary, we need to divide by 2, right? Divided by 2. 3 divided by 2, it goes one time, balance 1, right? So write in this reverse order 1 1. So it is 1 1. But we need 3 digits, so add 1 0 and the MSB 0 1 1, right? So the 3 is converted into now binary 0 1 1. Now take 2. 2 divided by 2. It goes one time, balance 0. Write in the reverse order 1 0. But we need 3 digits. So add 0 here. So 0 1 0. This 0 not having more effect because of MSP, but this 0 having more effect. If the 0 is not added while combining the value will change. So we must add the 0 here. Right? Now 3 is converted into binary having 3 digits. 2 is converted into binary having 3 digits. Now we combine these two digits, these two values 0 1 1 0 1 0. So this is nothing but a octal 32, the binary equivalent of octal number 32, right? 0 1 1 0 1 0. Now we will convert this binary into hexadecimal. How will we convert binary into hexadecimal? This given binary number should be grouped into 4 digits. While going to hexadecimal, we need 4 digits. Octal means 3 digits. Starting from LSB, we need to group into 4 digits. So here 0 1 0 1, 0 1 0 1, first 4 digits. Remaining only 1 0, 1 0 is there. In order to make 4 digit, another 2 zeros are added. So 0 0 0 1, 1 0 1 0. Right? Starting from MSB only we need to, LSB only we need to group, not from MSB, right? 0 1 0 1 first group, 1 0 is the second group. In order to make 4 digit, another 2 zeros are added together, right? Now we convert this binary into the hexadecimal. How to convert this binary into hexadecimal? Right? By using the weightage 8421. What is that 8421? This 8421 is nothing but 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, right? 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 means 4, 2 to the power 3 means 8, right? So we can multiply this multiplication, successive multiplication. For simplification, we wrote like this 8421, right? Here we wrote 8421, here also 8421. Wherever the 1 is available, that corresponding weightage is added. Wherever 0 available, that become 0. See here 1 is available, so we can take 8. Here 0 available, this 4 become 0. Another 1 is there, that is having 2. So 8 plus 2, 10. Right? Here also 0, so it become 0. So wherever 1 is there, that corresponding weightage should be added. 8 plus 2, 10. Here only 1 is available. Only 1. All others are 0, first digit. So 1 is means 1. That will be 1. Right? Other digits are 0. The corresponding, wherever 1 available, the corresponding weightages are added together. right? What is the 10 value in hexadecimal? 0 to 9. 0 to 9 is as it is. From 10 onward, it is alphanumeric. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F, right? So after 9, these numbers are represented by alphanumeric. So 10 is equivalent to A. So 1A, the final, and we can combine this 1A, right? So the given octal number first converted into binary by grouping 3 digits. Then this binary is grouped into 4 digits, that is converted into hexadecimal. The final answer is 1A, right? So we have two stages conversion, octal to binary, then binary to hexadecimal, right? Now we'll go to one more example. We have 746, another octal number. What we have? 746 should be converted into binary, then binary to hexadecimal, right? So first write this octal number separately. 7, 4, 6. 7 separately, 4 separately, 6 separately, right? Convert this 7 into binary number, right? 7 divided by 2, 3 times balance 1. 3 divided by 2, 1, balance 1, right? So while writing in the reverse order, 1 1 1, right? The 7 is nothing but 1 1 1. 3 digits are available. Now convert this 4 into the binary. 4 divided by 2, 2 times balance 0. 2 divided by 2, 1 time balance 0. Write in this order 1 0 0. The value will be 1 0 0, right? Then convert 6 into binary. 6 divided by 2, 3 times balance 0. 3 divided by 2, 1, balance 1. So write in this order 1 1 0, right? So octal number is written separately. Each and every digit is converted into binary and written in 3 digits. Already all are 3 digits are available. Now combine all this. 111, 100, 110. So this is nothing but binary equivalent. This octal 746 is now converted into binary number. Now we'll convert this binary into hexadecimal. How to convert? We need to group this binary number into 4 digits. Hexadecimal means 4 digits starting from LSB. Starting from LSB, we need to convert, right? So 0 1 1 0 is the first 4 digits. 0 1 1 0. Then 0 triple 1. 0 triple 1 is the next 4 digits. Then only 1 is available, 1. So add another 3 zeros in order to make 4 zeros, right? Now the 4 digits are separated, right? First 4 digit, second and third. The digits are sorted, add zeros. Now by using this weightage, we already discussed, by using this weightage 8421, we can convert this binary into hexadecimal, right? 8421. See, this 1 is available at the middle. 0 1 0, so that first digit is 0, second and third. 4 plus 2 6. 4 plus 2 is 6. Here first 3 digits are 1, last digit is 0. So first 3 digit we can add. 8 plus 4 12, 12 plus 2 14, right? The last one is 0. Here only this last digit is 1, so it become 1. This 842 is 0. So what we have? 1, 14 and 6, right? So this 14 is nothing but equivalent to E. Just now we discussed, right? The 10 is nothing but A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F, right? So the 14 is E. So we can write 1E6. The equivalent, the binary, the hexadecimal equivalent is 1. The 14 is nothing but E in the hexadecimal number, and 6. So 1E6 is the final answer of the converted into hexadecimal, right? So we have octal to binary. The first, the given octal number is converted into binary. How? Each and every digit is written separately, converted into binary and written in 3 digits. How all digits are combined together. While converting binary to hexadecimal, this binary number is grouped into 4 digits starting from LSB. Every 4 digit is converted into hexadecimal by using the weightage 8421, right? Thereafter it is combined together. 14 is nothing but E. So the final answer is 1E6, right? That is the final hexadecimal. So in this video we discuss two examples for converting octal to hexadecimal, that is from octal to binary and binary to hexadecimal. Other conversion system also available in separate videos. Details are available in the description box. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.